welcome on Watches TV. Welcome at the EPHJ Trade Fair 2023. And today we're going to talk about innovation, because each year there's a Grand Prix here that is organized with some of the exhibitors showcasing some really clever and innovative solution applied for watchmaking. We're going to discover the 6 nominees, and ultimately, obviously, we're going to discover who won. So let's go.
Congratulations on winning the Innovation Prize. Could you tell us why you won it, with which innovation you won it?
First, it's great. It's really great because it was a lot of work. A year ago, we decided, since we were asked by our customer, our watchmaker customer, to integrate, to supply the rotor with the miniature bearing. So we decided, yes, we will do it. So we launch ourselves in the oscillating mass production. But we said, meanwhile, we have a year to propose to the market an oscillating mass that never exists before, and that has a feature that can give a new capacity, new quality to the rotor, to the market. And we did it after a year. We did some brainstorming, and we issue a very innovative new oscillating mass systems. This is patent pending also. It's really simple. What we did is, actually there's different technique to make the assembly of the mass on the miniature ball bearing. There is with a device that you screw over the bearing, or you can fix it to press fit. So if you use press fit, then you cannot disassemble. With an outside screw that you screw over the mass, you have another piece that you add to the system, which is not aesthetic. So what we propose is to integrate. We have integrate all those features together. So the oscillating mass has a thread, and that thread is fixed to the ball bearing. It's a very, very precise thread, and we did some tests and HIS and tests for the mass, the vibration, to really secure, and it is fully secure. So we have something that is simple, can be disassembled, that relieve the watchmaker from the danger of destroying either the bearing or the mass, because it's an easy and simple assembly.
Percipia Robotics is a supplier of robotic solutions for mass production in microassembly. As such, our job is to co-develop with our colleagues and our customers the processes they need for ultimate micro-assembly in mass production. Our keywords are, I would say, accuracy, of course, first, small component size, flexibility of the usage, robustness of the application, and I would say finally scalability. I mean that we are able to support our customers' needs from a few prototypes with cobotic solutions, from very high mass production stages in which we are able to assemble thousands of products a day with ultimate accuracy. We've been nominated for a product which is called Tulip Gripper. So as we are making microassemblies, the first job is always being able to catch a component. We usually do that with the piezo gripper, which is the original gripper which we developed like 10 years ago, which is able to grab very small components. This product is great, but we need something more robust, faster, able to withstand some accelerations. So we've been developing Tulip Gripper, which is a miniaturized gripper which can grab components from 50 microns in size to a few millimeters, is more robust than its predecessor and easier to control. So that's, I would say, an easier access door for us and our customers to manipulate small components.
Grindosonic is a high-tech company. We are a spin-off of the University of Leuven. Our headquarters are in Leuven in Belgium. And it's now since 4 or 5 years that we have the 7th generation of this system, which is the MK7. The principle is resonant testing. So with a small impulse, we bring the object under test into its own vibration mode. And we measure with the system the vibrational frequencies and the attenuation, which is a measure for the internal friction and the concentration of micro cracks in the material. It helps to first develop new materials, to improve the full production process, so process engineering, step by step. We can measure before and after every step in the production, the sintering process, the rectification process, the polishing process step. We can measure the stability and the performance of those steps, and at the end we measure the total quality of all the produced parts, so 100%. It's quite innovative, and it's a very performant tool for the watchmaking industry to get the full production line under control for all the mechanico-elastic attenuation parameters.
EPHJ is a big company, 15,000 persons. We are present in 3 big markets. One is piping system, the other one is automotive or casting solutions. And here you are for machining solutions, different kind of machines. EDM, so it means erosion machines, wire cutting, die sinking, and laser machines, laser ablation, laser micro machining, laser texturation, and laser cutting. And here we are in front of a laser cutting machine, and as you know, we were nominated for this machine because here we have a specific opportunity on this machine. This is to cut with very straight walls, making what we call in French anglage, so chamfer, and also micro machining. To do that, we have here the possibility to shape the laser source. Here we have a 5-axis scanner. We call that a precision head. So we have 5 movements here, and we could have 3 to 5 mechanical movements also. Just to imagine, in fact, it's to be able to be sure that the laser shape, laser is light, huh? And this shape is normally like that. So it's a cone, and this cone has to be compensated by different movements. That's why we need this complicated head, precision, which is moving the laser in different directions. So we have 5, as I told, rotating like that, and positioning in Z also. And if you have complicated parts, we can also move here on the table. So if we look here, we were cutting, we just stopped the machine now. This is the head. We were cutting here. We have a neutral gas to be sure that we have no oxidation. And what we cut it here, we can see, in fact, that's the shape. We have a gear. A gear could be machinated also more classically on other kind of machine, wire erosion, for example, or stamping tools. But if you see at the bottom here, we have a spring on the same part. So we have one very complicated part with all those different shapes. And here, by doing that, or in fact, it's only possible to produce that on this kind of machines. That's the Swiss knife for laser machines.
L'entreprise Henri Chaler SA est une société indépendante de 3e génération, donc, qui a été fondée par mon grand-père en 1955. C'est une société qui est active à ses débuts dans l'horlogerie, et puis finalement, au fur et à mesure du temps, on s'est diversifié sur d'autres secteurs, On a plusieurs cordes à notre arc, donc on fait de l'injection plastique, on fait de l'étampage, du décolletage de joints d'étanchéité et également de la mécanique. Effectivement, on a été nominé cette année, on a ressorti un vieux dossier qui date de 1986 qui était finalement un inventeur avait inventé un système qui permet de réguler la pression dans les aérosols en remplaçant les gaz liquides qu'on connaît aujourd'hui, butane, propane, isobutane, par de l'air comprimé. Donc c'est un système qui permet de pulvériser que ce soit de l'eau, que ce soit de l'alcool, mais aussi de la peinture. Donc finalement, ça peut être une solution qui est également industrielle pour l'industrie horlogère, pour l'industrie en général. On peut finalement faire avec ce système, sprayer un peu tout ce qu'on veut. Donc je pense que ça peut être une solution effectivement intéressante pour l'horlogerie à creuser.
We are a company from Lithuania. We are integrators. We are integrating femtosecond laser into a machine. We did home research and we saw that our capabilities to produce parts from glass and from various polymers would greatly suit the watch industry. Yeah, so we can offer fabricating parts, again, with high resolution, high precision. And if there is a need for glass parts, we are here to represent.